Hello and welcome to today's Learn at Lunchtime program from the State Museum of Pennsylvania. I am Beth Erickson. Our topic today is the ice volcanoes of Erie. And with us is Adam Ianno, geochemist for the Pennsylvania Geological Survey. Hello, Adam, and thank you for being part of today's program.
Hi, and thank you so much for the invitation. It's wonderful to be a part of this.
So tell us a little bit about yourself and what you do.
So by training, I'm a geochemist. So I focus on the chemistry of geological samples. And interestingly enough, I'm also a volcanologist, a petrologist, a structural geologist. Basically, I focus on all kinds of hard rock uh, focuses. So like really igneous, metamorphic, and other rocks like that. And at the Pennsylvania Geological Survey, I serve as the head of our mineral resource analysis division. So we focus on solid resources across Pennsylvania.
So the words ice and volcanoes evoke completely different ideas, opposite temperatures with one being cold and the other one being hot. How did ice volcanoes get their name?
It's a little bit contentious, just because, as you can imagine, it's not volcanic, but it really evokes volcanoes. So if you ever see one of these things forming or out on a lake, you'll see water splashing up and out. Just resembles a volcano.
Well, we want to learn more about this, so let's get started with today's programs. So, Adam, when you are ready, we can begin.
Great. Well, again, thanks so much, everyone, for being a part of this. Happy to share this fun little project I've been working on off and on at the Pennsylvania Geological Survey. Um, what you're seeing here, unfortunately, is a little bit of a bait and switch. So there is no active lava flows or anything fun like that up in Erie. This is actually a volcano in Indonesia, and what you're looking at is burning sulfur coming out of that volcano. So thankfully in Pennsylvania, we don't have to worry about any sort of hazards like this, but I mean, certainly evokes an image, right? So I'm part of the Pennsylvania Geological Survey, which is a bureau of the Department of Conservation and Natural Resources. So you may ask, I mean, what do we do? Our bureau is split up into three separate divisions that focus on geologic mapping, geologic resources, and geographic information services. So what that means in a practical sense is we have a dedicated staff of mappers that actually go crisscross Pennsylvania trying to find different geologic features, different superficial features, groundwater, surface water, subsurface. If you ever see one of our trucks out in the field, please stop by and talk to one of our staff members. We're happy to share what we're doing, and we're out mapping Pennsylvania. In terms of resources, we have two sections, including one that I'm part of, that focuses on our mineral resources and just being responsible stewards of these resources. We pursue a lot of scientific research, trying to help out and understand more about our Earth, and also try to, again, be good stewards of our resources and use them responsibly. All of this is factored in through our Geographic Information Services division, which also serves our library needs and our museum and other collections. So all this data that we get from mapping and from resources, our Geographic Information Services staff helps us out, creates beautiful visuals, geologic maps, as well as pursues their own projects like mapping the streams of Pennsylvania. We have a drone operator that's also out there looking at road cuts and quarries and things to that effect. So we have a lot of interesting projects going on at the Geological Survey. But also, as part of the Department of Conservation and Natural Resources, it's a strong focus by Governor Shapiro and our Secretary Dunn to focus on outdoor education and outdoor recreation. So in addition to all this kind of stuff we do, we also put out a number of different publications that focus on outdoor recreation. So I encourage you to check out one particular one, our Trail of Geology series. We focus on geologic features that are present throughout our state parks. We're a sister bureau to the Bureau of State Parks. So, I encourage you to support the DCNR any way you can. That said, all of our data, our publications, the Trails of Geology, as well as our magazine, Pennsylvania Geology, can be found on our clearinghouse that's called PA Geode. The URL for this is a little bit complicated. It's listed in the bottom right, as well as a QR code available for you. But if you just go on your favorite search engine and search for PA Geode, it will likely be one of the top hits that you find on this. So please come check us out. go figure out an interesting part of Pennsylvania and learn a little bit more about it. All right, so what is an ice volcano? Like I was saying before, these things have a little bit of a contentious name just because they're not true volcanoes, but what do we call these things? So throughout the literature and throughout folks that live on the lakeshore that talk about these things, you'll see them referred to as mounds or cones or dunes or volcanoes. And you can just see from the two pictures on the right, one of them looks mostly like a volcanic crater, whereas the bottom picture, you could convince yourself that it looks like a series of sand dunes. What these things basically are cone-shaped deposits of ice, sediment, rock, snow, footprints, bird feathers, things like that, that form in the winter on lake shores. For these things to happen, though, there has to be very specific conditions. So we're talking about air temperature below freezing. We need to have below freezing to have ice. We have to have lake water that's liquid. We have to have wind that's blowing towards the shore. The wind speed has to be above 25 miles per hour. And there has to be a little bit of freezing that happens beforehand. So pre-existing lake ice, people also refer to this as fast ice. Very scientific diagram of how this was formed. Thank you, Microsoft Paint. If you imagine that your land surface is up on the top of the screen and your open lake water is down below, there's a shoreline that exists, of course, and I draw it as a squiggly line just because the shoreline is never straight. There's always variations in it because of offshore bars or rocks or various other things that impede there being a completely smooth surface. So this is our starting condition. Imagine a bunch of freezing that then occurs. So starts freezing right next to the land just because it's very shallow there. It's a nice place for ice to start nucleating and growing and crystallizing. If the conditions are just right, that ice will begin to grow outward towards the more open part of the lake. We still have open water, unfrozen water down on the bottom, but the ice is creeping outward. And because the shoreline is uneven, the ice also grows out in an uneven fashion. Keep this going, you'll progress that ice growth even further out into the lake. The jaggedness of the ice becomes amplified with every motion outward towards the lake in general. And so those irregularities that you see on the shore become more prominent. And this sets us up for the perfect conditions for ice volcanoes. A paper that came out in 1973, which is probably the pinnacle of folks that looked at this thing a little bit further up in Dunkirk, New York, so 60 miles or so northeast of Erie. What you're seeing here is a diagram that represents the lakeshore with ice volcanoes growing on it. They show the lake being roughly 100, and it's just an arbitrary number that they try to show just for relative difference. But what you're seeing here is those little irregularities make those cusps that you see, the four cusps that poke out across the screen. The lakeshore off in the background, off to the top. So as those waves keep going in, you see incredible growth. So the ice isn't not only growing out into the lake water, it's also growing up. So the part I highlight in a circle there shows a little number. It says 105.8 as compared to the rough 100 average of the lake that they tried to represent before. This thing has grown 6 feet. So how this works, the waves of the liquid water that still exists out towards the lake are being funneled into those little channels. So as they funnel, it drags a bunch of water, scrapes a bunch of sand off the bottom, including rocks, and slams against that ice wall. Water splashes up and out. As it splashes up, the arrows in blue, it hits that wall and it spreads out back towards the shore. That water can't go anywhere. It's already trapped behind that giant wall or fortress that we built up because of the ice there. The rest of the water will bounce off that face and splash back into the ocean. But all that water, sand, ice chunks, what have you, that made it up and over, then gets locked and embedded into that ice structure until the spring or the next melt happens. Looking at this in a little bit more of a three-dimensional perspective, I took a section out of one of those cusps just to try and take a cross-section across it, a three-dimensional cross-section. So what you're looking at on the left was the image from before. It's a top-down view. What we see on the right is actually a side view. If you imagine just taking a cut straight through one of the cusp there. So the open lake on the right diagram is off to the left-hand side, and the shore is off to the right-hand side. And what we see, again, fortress of approximately 10 to 15 feet tall in its biggest form. Water will splash up and over, but once it gets over that top, it can't slosh back into the lake. So it sloshes back towards the shore, and it just keeps on growing. Now imagine this happening a whole bunch of times. This is how you can actually get upwards of 20 feet of ice just from splashing on the lakeshore. So in looking at this, I went up to Presque Isle State Park, and I want to give a big shout out to the Tom Ridge Environmental Center there. If you've never been, please go. It's a wonderful place, open all seasons as far as I understand, and wonderful museum space and wonderful staff. The park itself lies beyond. You can see a spit with trees that goes off into the distance. One thing I actually want to point out here, and thankfully, well, I mean, the weather in this picture is a little bit better than the one I had when I was fortunate to visit up there. But what you'll see in the background are a series of embankments or bars that you see offshore off onto the left-hand side, or what would be the northwestern shore of the coast. Those are little breakwaters, and those will come in later. So make note of that. What you'll also see off into the top right-hand picture is Presque Isle Bay, still bay behind, which again is why Erie exists where it is. It enables all of its industry and such, as well as ice fishing. So looking at the park map, again, there's those breakwaters, this time represented in blue. These are just breakwaters that are made out of large riprap, large stones, and the goal here is just to baffle the waves a little bit, because I mean, this is an important beach, this is an important landscape, and the goal of this is to try and protect it a little bit. Now, geologically speaking, we know that whenever folks and engineers build these breakwaters, there are features that build up behind it. What you see on the shore are also little cusps that point towards each of these breakwaters. That's intentional. So not only do these things break the water, but they also allow sand to deposit behind. And it's great because this is a beach people visit at. This also is part of the conditions where we create a shoreline that's not completely flat. So what you're looking at here is the northernmost tip, give or take, of Presque Isle State Park. The area that had the most prominent ice volcanoes on the day that I visited was Sunset Point. This is just luck in this case. It's all contingent on which way the wind was pointing that season, as well as the freezing and thawing conditions. So this year it may be different. This year we may not even have any. It all depends on the weather conditions. So first off, if you are fortunate enough to make a trip out to Presque Isle State Park, there are signs everywhere that warn people to stay off the ice dunes or ice volcanoes, depends on what you want to refer to them as. This is very practical. I mean, these things are hazardous. You are walking out onto the lake. So I don't recommend you traveling onto the ice volcanoes, but if you must, be sure you know how thick the ice is under your feet. Make sure you have an idea of what the weather conditions were beforehand. You don't want to punch through ice. When you're looking at this wonderful landscape, it's actually kind of hard to tell what's truly sand. Am I standing on the beach? What's snow? Is there a snowbank that's covered over with sand? What is ice? So you have to be very careful about where you're stepping. Second of all, it's the winter. You're on the lakeshore. Do you have the appropriate gear? So, I mean, obviously winter is cold and ice is slippery. So make sure you're prepared for that. But the thing is, I mean, falling into Lake Erie in these conditions can be deadly. Hypothermia is something that you do not want to be witness to. So if you are going out to the lakeshore to see these things, not a sales pitch here, but consider some sort of crampons. I used Yak Trax, if you're familiar with that, similar to crampons, but like a little less likely to harm your floor, a little cheaper as well. But do what you feel is right in the moment, but just make sure you're safe. So getting out to Sunset Point, what we see here is a series of ice volcanoes covered over in snow, covered over in sand, dirt, and things to that effect. In the back, or in the far of the picture, you'll see an ice volcano that's relatively dark, off on the left-hand side, created in the same process, sand, water, ice, up and over. This one, particularly from how it was formed, was able to dredge up a lot more sand, so that's why it's a little bit darker. But also, before this visit, there was a period of warmth for about a week and a half or so. So there was a lot of melting that happened, and in the process, ice melts, but sand doesn't. So the sand concentrates. Now, because sand is actually darker than snow and ice, this darkness will also help absorb more of the sun's rays and aid the melting. So each one of these ice volcanoes has a separate microclimate, if you want to think of it like that, and they all have different features. But the things I want to point out here, there's a row of ice volcanoes in the distance, including that dark one. But if you look more closely, there's also a series of other ice volcanoes. So there's rows of these that come up. The white bay of sorts in the area was liquid water the day before, covered over with a dusting of snow. Probably not safe to walk on, but I'm standing on the shore here, and even the shore itself, which was slightly elevated off the lake level, has some form of ice volcanoes that had formed on it before. Slightly different perspective, standing back on the beach and looking at that dark ice volcano off on the right-hand side. And as you can see in the distance, and there's a little bit of a mirage that's going on, the water is mostly liquid. It's starting to freeze a little bit. It was a very cold day when I was taking these pictures. It was about 15 degrees Fahrenheit. So the lake was starting to freeze overnight and things were warming up for the day. Standing on the beach, we still have that bay. We have a series of ice volcanoes at the edge of the bay in the middle of the picture, vertically, including an escape hatch, which looks like that little cave that you see on the left-hand side, as well as at least 2 or 3 more rows of these things. Again, there were multiple events of ice volcanoes that came up to this point, and this was February 2022, so at least a month or so of favorable conditions off and on. Looking at one more closely, what we're seeing is an ice volcano that was one of the original first to form, and ever since, it's basically been packed in and covered over with snow. So the vent, or whatever you want to think of it as, where the water was splashing out in the middle there, is that U-shaped cusp of sorts that's pointing upwards. You can see all the sand that splashed up and out, resembling a volcano for the most part. But snow comes in there and covers it all up. And this is where things can actually get hazardous as well. So if snow is drifting and banking up in there, you don't necessarily know if there's still an open hole that's pointing out to the lake below. So exercise extreme caution by trying to go in one of these things. You definitely don't want to poke through and risk hypothermia. Little side note, I was fortunate enough to visit the Litlithlutur eruption in Iceland this summer as part of a class that I was teaching. And you can start seeing the resemblance of an ice volcano to an actual basaltic spatter cone volcano. So we call it a spatter cone just because you can see that reddish lava fountaining out and spattering around. Imagine that's water. That's essentially what's happening with that splashing effect. Now, granted, volcanoes are much hotter, of course, but there's pressure differentials and things that are technically different. So ice volcanoes aren't really volcanoes from a strictly physics standpoint, but again, the resemblance is uncanny. So I feel it's actually a pretty good descriptor of what we're looking at here. Thankfully, Pennsylvania doesn't have these things, or life would be a little bit more interesting in the Commonwealth. Looking back at Sunset Point, I'm standing on the rim of one of these rows of ice volcanoes. It's attached to the shore, slightly offshore, but you'll see snow embanked on and all the cusps that are still present there. So the undulating, wavy nature of the right-hand side going off until to the shore is one row of those ice volcanoes. Now, each one of those embayments was an area where water splashed up and out, but no longer, because there's lots of ice that has grown since then off to the left-hand side. But you see all the snowbanks that are piling up, presumably blowing from the left onto the right. And this, again, fills up the whole area. Ice volcanoes can form on top of that and such. But you'll start seeing the different rows of ice volcanoes that have popped up. I mean, there's probably at least 4 or 5 I can count here, just just looking at it so briefly. But the middle of the picture, looking vertically, has a series of larger ice volcanoes, somewhat wider, but you can see the cones, so to speak, that are poking out here. And some of these have dredged up more sand than others. This probably has to do with the depth of the lake underneath it. The lake here isn't terribly deep, so if these waves have enough energy to push on in and dredge up sand from the bottom, you'll see it sprayed out on top. The edge of the ice volcanoes is the top of the picture, and that's where the new growth would happen if it didn't freeze so quickly the night before. So there's actually new ice that exists right on the other side of that. I did not go up to the ledge, but you could see it from a different perspective. So the conditions weren't right for growing more here and now, but if they were, that's where they would end up growing. These things form not as perfect cones. If you remember the first diagram that I showed, they start off as embayments or little cusps that can close off with time. So this one did not make it. What we are seeing is the cusp that forms and the opening that shoots off towards the top of the image. And again, these things build up a lot of water and ice and splash on over. The top of the cone there is the tallest point in the image, despite the perspective that I took the picture at. But you can see all the sand and the water and the ice that has splashed out of it. And whatever made it out towards us freezes in place. Whatever didn't sloshed back out into the lake to be seen again later. But again, you see the snowbanks that are filling up the cusp in the middle. Who knows what's under there? So be careful where you're walking. Looking at this from a side perspective, you can actually start seeing the growth of these things. So when you're forming an ice volcano, these things can actually grow by 3 inches every splash if the conditions are just right. Because you splash that water up and out, if it's just right, it'll freeze in place. It can't go anywhere. So these things can build quickly. They do not have to. But what you'll see, and it's a little bit in shadow, if you look inside the cusp of that it's the same volcano as the previous picture, just a side view. You'll start seeing alternating stripes of dark and white. So those stripes, the white may be snow, it may be more pure lake ice, but the dark layers are the sand that's splashed up. So without being there right now to fully dissect it, we could be looking at a series of maybe as little as like 8 waves that splashed on there. Now, chances are this thing grew a little bit more slowly, and that melting process that I talked about, if you splash the sand on up, the sand absorbs the sun's rays and starts melting some of the ice, you will start creating and concentrating some of these sand horizons. So that may accentuate that dark and light striping. Hard to say from this perspective, but just looking at the surface that you see here, so the part of the ice volcano that's pointed towards us, as well as the extension of it to the bottom right of that picture, you can start seeing that the sand kind of falls into pock marks, so to speak. That's because, again, it's melting locally right where it is. The sun's hitting it directly. It's warmer than the rest of the ice, so it is actually actively melting a little bit in front of our eyes. Looking back at the leading edge of the ice volcanoes at Sunset Point, again, you can see the lake off into the top right of the picture, mostly liquid with just like a thin veneer of ice, so to speak. But these are the leading edges of the last major event of ice volcanoes. And at this point, we're actually standing on something like 7 to 8 feet of ice in and of itself, because this process had gone on for at least 2 months. It's accumulated more and more ice. Whenever the next waves would come in, they would splash up and over and keep building up on top. One part I wanted to point out to you, and you can probably see it most prominently in the foreground of the picture, so right up front, you see these large rounded ice potatoes of sorts. That I call it that because they're approximately the size of a potato or a sweet potato if you hold up one of these things. When the water is freezing and splashing in the area, you'll actually see ice forming in the lake. Now, with all the wave action, you'll get erosion and tumbling. Essentially, these little ice layers that are growing are being put through a rock tumbler. So you form all these nicely rounded ice chunks, and when a wave hits it just right, it'll send these things up and over the ice volcano front and splatter them out all along the background of it. So a lot of these ice volcanoes and a lot of these plains behind it are actually made out of these little potato structures, so to speak. Looking at it a little bit more closely, you can start seeing how well-rounded they are. These things look like they have been through a rock tumbler, and in essence, they have, because again, you have waves splashing back and forth. Not to mention, these things went up and over upwards of a 20-foot wall of ice and tumbled back down. There's a lot of sand there, so you even have your abrasive grit to help polish these things. So you get these things, they deposit, and then more water comes in, or snow, or sand, etc., to cement it into essentially a large uh, body of rock that has these things built up in it. Looking back at another ice volcano at Sunset Point, this time facing the shore instead of the lakeward, you'll see that the cusp is where I'm standing, and we're looking back in. And this one was built up enough that it actually encrusted all the way around to form that perfect volcanic cone. But if you look at the sides of it, not to mention the middle of it, you'll start seeing those potatoes of sorts. So there's a couple prominent ones that exist off onto the left-hand side, but you could also see them right in the middle. These become part of the structure. This is evidence that they actually come up and over and splash out when the waves are just right. Again, maybe a better perspective. This is the cusp of an ice volcano at Sunset Point. There's a little bit of melting, which explains the pock marking and divoting that you see there, as well as the grayish color of the ice. But you see all those potatoes sitting there. Looking back, again, a good perspective of the different rows of these things. So the shore is where I'm standing a little bit off screen. Um, you'll see a row of mostly sand, but there's a lot of snow and ice present on there. I'm not completely sure if that's the coast or if it's actually just a sandbank that's been splashed over with sand. But there's other rows going basically from top left to bottom right of these ice volcanoes. And you could start to piece together the structure and the sequence of events that happen here. The earlier ones were definitely occurring off onto the left-hand side, and the later ones are off to the back and to the right-hand side. And again, this must have taken 5, 6, 7 different events to grow these things, but it happened relatively quickly. So these things can happen in the span of 2 months, even with a lot of melting and a lot of warmth that's happened beforehand. Presque Isle Lighthouse was a little bit down the way, and this is just case in point. So I was stepping off the shore, trying to peek at one of the ice volcanoes, and I looked at it and said, "Oh, okay, yeah, this should be easy. Let's just walk right onto this thing." And I sunk into probably about 8 inches of snow. If you look at this, it just looks like sand. I had no clue that there was a sand or a snowbank under there. Fortunately, no lake water, no incidents of note, but point being, it's hard to know what's truly sand here. Is this the beach? Is this a snowbank? Is this ice? So exercise caution when you're walking around these features. You may not know what you're getting into. Presque Isle Lighthouse, again, was a little bit down the shore off to the southwest, but it had slightly different features that we saw. The lake was more liquid closer to the shore, or at least closer to where you can access the shore. And you can just see from the previous night, there's a fence post that's embedded into this ice wall that's poking out, and that was approximately 5 feet, 6 feet or so. But with all the melting and with all the refreezing, this has turned into a giant wall of icicles and snow and ice. This is a human-made feature, so it's not necessarily an ice volcano. However, this may actually act as a framework for an ice volcano to build on if the wind was pointed in the right way, as well as the waves. There were ice volcanoes present here, but because of all the melting from the week before, they had started to rapidly decompose. So this row of ice volcanoes, which is arcuate and sort of curves around off to the right and then back again into the background, these all used to be ice volcanoes, but because it was liquid the day before, just the slosh that you see off to the right-hand side, that was liquid water the day before. So with warm conditions, with wet water, or non-freezing water, I should say. Water is always wet, of course, but we start seeing these ice features cracking apart. Now so the decomposition of these things is also happening in the other area in Sunset Point, but we didn't really have a first row view of what we were seeing because in that space, much more water had come in and frozen over, snow banks had happened, and sometimes all the features of these ice volcanoes just get beveled over with other events that are going on. Fortunately, Presque Isle was home to maybe the most iconic ice volcanoes that I observed. So what you'll see here is a relatively perfect, for what it was, ice volcano pointed out. The lake shore is pointed off to the top left-hand side, and you can see there's a little bit of an opening that still exists. It didn't freeze completely over, but it's about 3 or 4 feet tall down to the lake from here. And you can see just a little spray of sand just splashing out. You can imagine water that came up, took that sand and splashed it all out in all directions, which resembles what lava would be doing in Iceland and other places that have lava-based volcanoes. You could also see those little ice potatoes again that came up and out and splashed out and will freeze into the structure, waiting for its next wave. Looking deeper into the light or into the ice volcano itself, you can start seeing those ice blocks frozen into place, as well as snow and other ice chunks that froze into the vent of the volcano itself. Further down the shore, about 100 feet or so, in that same chain, this area was significantly impacted by melting as well as liquid water coming in and eroding away the features. However, it was deepest one that I was witness to. So if I were to stand in that, and I'm about 6 feet tall, I would come up halfway. So I approximated this thing was about 12 feet tall from the lake to the top, but with erosion and with melting and with snowbanks and other features that distort the shape of these features, you start, it's a little bit more difficult to tell what's going on. But you can see all the melting that had occurred because the sand off on the right-hand side, again, is pockmarked, pitted, and otherwise concentrating itself to form a darker horizon, which again aids more melting and causes this thing to disappear for the season. So that's just a little brief snippet about the ice volcanoes of Pennsylvania. Again, they're a very ephemeral feature. The conditions have to be just right to see them. But if you're lucky enough to be there in the right place in the right time, it's a wonderful place to go visit. So all the same, I encourage you to go up to Presque Isle State Park, summer, winter, what have you. Wonderful place to go. And I also encourage you to reach out to us at the Pennsylvania Geological Survey. We're here for the residents of Pennsylvania, as well as folks beyond. Anything geological in Pennsylvania, we're your folks for it. Always happy to help. Thank you so much.
Thank you, Adam, for sharing that information. So let's get to some questions, and we're going to start with one that's on, I think, everybody's mind. Is the term ice potatoes an official geologic term?
I came up with it on the fly, but I really love it as it were. So if anything, I'm gonna push to make it happen.
I think you should. It is a perfect term to describe what we were looking at. That's fantastic. So a couple questions. Where else on Earth have you seen ice volcanoes that maybe you wouldn't expect to?
I haven't personally seen any in other locations. However, anytime you have a lake shore with the right conditions that are conducive for growing, you can see them. So folks have traditionally seen them on the southeastern shores of Lake Erie, particularly in New York, where the wind conditions and temperatures are just right. But folks have seen them on the south shore of Lake Ontario. People witnessed it on the other Great Lakes. Sometimes it gets a little bit too cold up in Lake Superior, so not so much, but folks have also seen it across the world. So like Sweden is a place. Believe folks saw it in Lake Baikal in Siberia, as well as other smaller to medium-sized lakes. So really, if you have fresh water, you have a prevailing wind, and you have the right conditions, you can have them. It's just that those conditions are so particular that they don't always form even in Lake Erie every winter. So got to get it
Well,
right.
that leads perfectly into the next question, which is what conditions might occur to prevent them from forming?
So temperature is a big one. It has to be cold enough for the water to freeze when it impacts and comes up and over that ice wall itself, but the lake still has to be liquid. So oftentimes this results in conditions where the water is either super cooled, so it's still liquid below its freezing temperature because there's enough motion and wave action and things like that, or it's uh, I was going to say the waves probably will be the biggest impactor for why you can't get it to freeze. Now, the other side is if the wind's pointed the wrong way, you can't freeze it. You need the waves to push up onto the shore as compared to away from the shore because you have to have ice for it to glom onto, to freeze onto, to create this and continue the process.
Well, it seems like Lake Erie is a good location to provide the conditions needed for this. So, what determines whether a dune shape is formed or a volcano shape? And do ice volcanoes shoot out water?
They do shoot out water, and I was really hoping that I would luck out and see a splash that occurs. There may be some YouTube videos. I know that there's some dedicated people up in Dunkirk as well as other coastal towns in New York that, as well as in Erie, that witness these things. So look at YouTube for one. But um, in terms of dune versus volcano, it's somewhat semantics. So the perspective on what you're looking at it, like are you looking at it from top down or the side, could gauge whether you want to call it a dune or a volcano. The dunes typically are referred to as dunes when they're open on one side. So if they're the leading edge pointed towards the lake, or like that picture in Presque Isle where they start cracking in half and the other half of the cone falls off and uh, floats away into the lake, that will give an appearance of a dune as you're looking out towards the lake. Now, with the volcano, since it's formed in those little slots, those cusps, what happens is if you just keep splashing up and over and growing and growing and growing, with each incrustation, and when it splashes, it doesn't just splash over just that leading tip, it splashes over the entirety of the wall. It'll keep growing out until it finally connects in the middle. Now, the downside with that is once it connects in the middle to form that perfect, beautiful volcanic cone, then the odds are you might be blocking the hole that the water is actually coming up and out of. But in this case, then it'll just continue growing outwards towards the lake.
Could an ice volcano occur in a pond where there's enough wind to create the waves?
It can. I wouldn't expect a 10-foot wall, of course, but if the conditions are just right, you may actually see little ice volcanoes that may be a few inches tall, but it's the thought that counts, right?
So there's a question about the scale. You mentioned the one ice volcano that if you could have stood in. Are they larger towards the edge of the lake water and or is there a difference as it builds up? Where exactly, like what is the scale? What is the size of them? And depending upon where they're located on the lake.
From my recollection, I believe the biggest one that was ever observed was something like 40 feet tall in Russia. But in Lake Erie, they typically top out at about 20 feet or so from the lake level. And again, that's a little hard to assess because you don't really want to be finding the lake level for yourself, of course. But they typically are biggest towards the outside of the lake just because there's more open water to splash in and catch and more energy that exists there. Now, to make waves themselves, though, uh, when you have wind that's blowing across a lake surface, so in this case, you're blowing across Lake Erie, there's little friction that happens between the wind and the land surface. So on land, there's trees and buildings and things like that. But on the lake, it just builds up and continues. So all that energy gets put straight into the lake. And when you get close to the lake shore, the shallower the shore exists in that area, the more of a splash you can get. So in some sense, you want to be out towards the lake as much as you can, but in an area that has relatively shallow wave base, we call it. So the depth to the sand below a hand. So once it gets there, then you can really create big splashes. But having that large amount of energy from a gust of wind blowing a long distance, as well as having the lakeshore being right, really controls the height of these things.
You mentioned artificial breakwaters. Could you
Yes.
talk a little bit more about them? What material is used to make them? Are they above water, underwater? How tall are they?
A little bit of both, yeah. So it varies where you're at. There's folks out in California and such that make these things out of concrete. However, in Presque Isle, they're made out of giant limestone boulders. So we're talking car size or so. So folks probably by barge, possibly by land-based machinery, take these things out there, build, I believe, 100-foot long, 50-foot long breakwaters in the water such that they pop out about 6 feet or so. And the large nature of these stones is just so that it won't erode away or be pushed away by the wave energy, but it's there to let the waves break into them, let the energy disperse across that big rock instead of blasting the shoreline and perhaps taking the sand away with it.
Are there any wildlife that take advantage or utilize ice volcanoes as a habitat, or are they too temporary a structure?
They are very temporary. I mean, they can exist for as little as a day for the most part. I am not aware of anything that uses these structures in a more seasonal perspective, and I didn't personally see any evidence of animals or anything to that effect. But that's not to say that there isn't a connection. So be something I'd be very curious to look into, to be honest.
So, what is the greatest number of ice volcanoes that you have seen in one area?
It was probably that Presque Isle area, the area that I showed at the end. I didn't take a count, although I probably could retroactively looking through my photos. But yeah, there was probably at least 200, 250 of them that you could see very distinctly. Now, I mean, Sunset Point, you can make the case that was a lot more present there, but because there was so much interaction between snow drifts and lake water and things, a lot of those features were obscure, and so there was likely a lot more there than I had thought. But yeah, Presque Isle I think was probably, or Presque Isle Lighthouse to be specific, was the most impactful for me.
That was fantastic. We really enjoyed the pictures and with some great questions. I want to thank everyone in the audience for your questions. And Adam, what would you like the audience to remember from today's program?
I think the big thing is if you feel the adventure of going out and seeing these for themselves, please be safe. I don't want to hear about anybody getting hypothermia or injuring themselves seeing something so fun and exciting and temporary. But please get the chance to take a peek at them if it works out for you.
Fantastic. So thank you, Adam, for being part of today's program.
Thank you.
And I want to ask everyone if you would like to join us again for more Learn at Lunchtime programs, please visit the State Museum's website at statemuseumpa.org for program information and to sign up.